In this video, I am going to go through question number 5, which is on forces from the AQA, specimen paper, paper 2, higher tier, and this is coming from the combined science, not the separate science physics, but it's still useful for the separate science as well, physics as well. So figure 4 shows a skydiver training in an indoor wind tunnel. Large fans below the skydiver. The large fans below the skydiver blow air upwards. So there's air movement upwards. 5.1, the skydiver is in a stationary position. Complete the free body diagram for the diver. So because the diver or skydiver is in a stationary position, the forces should be balanced. So you want to draw an arrow which is roughly the same length as this. So that's about 1.5 centimeters, or let's say that, yes. When they're marking it, they are roughly going to look at it, and it needs to be pointing downwards. So the two key points is an arrow of equal signs vertically pointing downwards, right? And it needs to be labeled as well, and the label is weight. Next question. Question 5.2. The skydiver now straightens his legs to increase his surface area. If he increases surface area, the drag or the air resistance is going to increase. This causes the skydiver to accelerate upwards. So the reason he's accelerating upwards, so if I draw a simple free body diagram, there will be more drag or air resistance. The weight is going to remain the same, so he will accelerate upwards. Explain why straightening his leg causes the skydiver to accelerate upwards. The upwards force is greater than the downward force. Explain. So you are giving a reason. Because the air resistance increases. Right? This is optional additional information just to make it clear. There is a resultant force upwards. So sky diver accelerates upwards. Question 5.3. A small aeroplane used for skydiving moves along a runway. The aeroplane accelerates at 2 meters per second from a velocity of 2 meters per second squared. Let me read that properly. From a velocity of 8 meters per second. After a distance of 209 meters, it reaches its takeoff velocity. Calculate the takeoff velocity of the aeroplane. The takeoff velocity from a velocity, that's my initial velocity, u. Acceleration is 2. Distance, the symbol is s. The takeoff velocity is my final velocity. So the equation that I need to use, which you can find from the equation sheet, is v squared equals u squared plus 2as, right? Final velocity squared is equal to the initial velocity squared plus 2 multiplied by the acceleration multiplied by the distance. So if I put or substitute the values, initial velocity is 8 squared plus 2 times the acceleration is 2 and the distance is 209. That gives me 900. That will be v squared. So v would be the square root of 900, and that will give me an answer of 30. Question 5.4. A skydiver jumps from an aeroplane. There is a resultant vertical force of 300 newtons on the skydiver. There is a horizontal force from the wind of 60 newton. Draw a vector diagram to determine the magnitude, which is the size, and direction of the resultant force. So they have given you a graph paper. So when you are drawing a vector diagram, you want to try and use the graph paper as much as possible, right? And you need to make sure that it's proportional. So if I start at this point, let's say they are saying vertical force of 300 Newton and a horizontal force, the direction doesn't matter, of 60. So let me take this point here, right? So if I take 100, 200, 300, so that's actually, so if I take 100, 200, 300, coming down this way as 300, so 100 is 20 boxes, so that will be 50. So this is also 100, so 50, and that's going to be my 60 point. So draw a straight line, label that as 300 Newton, and the horizontal wind of 60 Newton. So how do I work out the resultant force? Well, there's more force this way, so the person is actually going to move in this direction. So I'm going to draw a dotted line. And this point to there is my resultant force. So that is my resultant force. Now you can measure using the ruler, right? So this is a 1 centimeter graph, right? So how much did I take? The graph, because the way it's printed out, I'm not going to use the ruler to do this. I'm going to use Pythagoras theorem, which is a bit more accurate in here. So remember, if I'm using Pythagoras theorem, I'm going to use this phrase: a squared equals b squared plus c squared. So if that is my a squared and that's b squared. This should be my c squared. No. So using Pythagoras theorem, a squared will be 60 squared equals 300 squared plus c squared. So that gives me 3600 equals was it 90,000 plus c squared. So finding c would be the square root of 86,400. So 86,400, square root of 86,400, 293.9. So round it off to 294 meters. Now I've just checked with the marking scheme. The marking scheme gives me a range of 304 to 308. So the answer should be 304 to 308 meters. So that would be incorrect. So I need to go back to actually using the ruler. So if I measure that line, that's 11.2 centimeters, right? So, and if I measure it from there to there, that's about 11.4 centimeters. So let's see if we can work this out. 11.2 centimeters equals 300 Newton. So 300 Newton divided by 11.2, 300 divided by 11.2 will give me 26.78 newtons. That's for 1 centimeter. Because that's 11.4 centimeters, if I multiply this by 11.4, multiply that by 11.4, yes, that gives me 305.36 Newton. That should be within range. Right. So advice is, don't use Pythagoras theorem if you can avoid it. Use the scales properly. Thank you, and that's the end of this question.